So, in the first question it's asking us how we're going to split a variety of different hydrocarbons apart, and we know that we can do that using their boiling point through a process known as fractional distillation. The second B question is asking us what the name of the alkane is going to be. It's telling us that there's 9 carbons in that alkane. So we know that an alkane has a general formula of CnH2n plus 2. We know that there are 9 carbons. 9 times 2 is 18, plus 2 is 20. So we know it's going to be C9H20. In the third part of the question, it's telling us that it's got an 8 carbon chain as a straight chain and 1 branch as a methyl group. And it's asking us to draw the skeletal formula. Well, where you guys went wrong, firstly, rather than drawing the skeletal formula, you drew in all the carbons. Skeletal formula means a formula where you don't draw the carbons in. So you have different possibilities of where you can put the methyl group. Remember that you can number from either end. Remember that a methyl group on a terminal carbon is not actually a separate side chain, but it's part of the main chain of the group. Okay, so the first one would be 2-methyl-octane, which looks like this. The second one would be 3-methyl-octane, and the third one would be 4-methyl-octane. Because we can number from either side, 5-methyl-octane, it's not possible. That would be exactly the same as 4-methyl-octane, because we can number 1, 2, 3, 4. Okay. In question C, we're asked for the products of a cracking reaction. So we know that one of the products is ethene. We're told that in the question. We know that we're starting with C15H32, so therefore we're ending up with C13H28 as our alkane. The mark scheme for the part C, part 2 was quite specific. So you need to mention that because the carbon chain was long, there was lots of different theoretical points where carbon-carbon bond could be broken. So therefore you could have lots of different products in your cracking reaction. You could have lots of different alkenes and alkanes. In section D, the trick here was to recognise that the molecule that you started off with, which was a dimethyl hexane, already had the 8 carbons that you were asked to provide in the final molecule. It also had too many hydrogens, so it had 16 hydrogens. So you know that in the final compound you're asking for 12, so you have to lose 4 hydrogens. Well, you know that cyclo compounds are hydrocarbons in this case, and you know that you can have alkanes and alkenes. So alkenes have lost 2 of the hydrogens from the alkane, so therefore if you have 2 double bonds you'd lose 4 hydrogens. So there are a variety of positions where you can put those 2 double bonds. So the only requirement is that the 2 double bonds are not next to each other, that there has to be a double bond followed by a single bond followed by a double bond at least. Okay, obviously they can be further apart than that, but they can't be next to each other on adjacent carbons. And a final point as to why you want to make these cyclic compounds is because they're easier to burn. The reason why they're easier to burn is because they have a higher octane number.